Hey, all, Brad here with another quick video, hopefully. Uh, Today I've got a turkey shoot board set on the bench, including the gun board. Um, James over at Vintage Vault Arcade in Wisconsin sent it over. He used to have a turkey shoot. Circumstances arose, he had to sell it. Had a lot of regret about selling it. Now he's got this arcade, and really likes the Williams games and expanding it. And he was able to get his hands on another turkey shoot here recently, which needed some work. Wasn't in workable condition, so he's going through and restoring the cabinet. And the boards were kind of in an unknown state, so he wanted to send them in and have me go through, do the rebuilds on them, change all the components that I normally do, and make any repairs as needed, and get them back to them. So that's what we've done. So I'm going to go over that here with you today. So I'm going to switch over to the bench cam. I'm going to review what I did on the board. Then we will boot the game, go through a little gameplay and some diagnostic screens, and show you how these gun board works, the lights it drives, as well as show you the optical encoding, I guess, for the actual gun itself. So let me switch over to the bench cam, and I'll get up here and give you a little description. So this is the gun board. So this has been completely gone through. All new Molex headers on it, new bridge rectifier. I do put a heat sink on it. The original one didn't have this. Two of these large 3600 microfarad caps for filtering once it creates DC. There is another electrolytic back here that was replaced. Molex header. We got 1, 2, 3, 4, 5, 6, 7, 8 Molex headers new on here. And then again, fully tested, and I'll go over with that. Back here on the bench, we've got the MPU. This has got all new 1, 2, 3, 4, 5, 6 Molex headers with square pins. Back here, we've got the Nichicon filter caps for all the power coming in. There's also a little Tantalum I swap out back here for the soft start. Same circuit that's used on the other, Williams boards, the earlier generation. And then also got rid of the battery holder on here for the double A's. It did have some leakage. I had some cleanup on the board to do, and we've got a CR2450 battery holder in here now with a fresh battery for the to retain the settings and high scores and such. Also pull out all the socketed chips, all these EPROMs here. We've got 3 more here, and then back here we've got an EPROM for the sound CPU, the game CPU 6809E, and then both of the blitters. And again, these use the special chip 2s, the SC2s. The original blitters that were used on Joust and Robotron and all those actually had an error in them that they never intended. D2 was inverted, so they actually fixed it on this version, and they're not compatible with each other between these. They started with Splat, and then it carried through all the Gen 2 boards here. Back here on the video board, again, we've got new Molex headers here, new electrolytic caps over here, socketed chips pulled, including bipolar over here, cleaned. This one got a full Simple Green bath, stripped down, soaked in Simple Green for about 20 minutes, scrubbed with a brush, rinsed, and with pretty warm water, and then I rinse it with RO, reverse osmosis water, so we don't leave any conductive minerals behind in regular tap water, and gets thrown in the oven and baked. Dries it off by about a half hour to 175 degrees Fahrenheit, and then we get it back down, and I reapply any paper labels I'd removed. A little straighter than they probably were originally. So that's kind of the setup on the what I did on it here. We didn't find any real smoking guns with things that were preventing it from running. I assume some of the cleanup on here. We did find some cold solder joints on the power distribution, which could be problematic on these. So I typically don't try these, running these boards ahead of time, just due to the fact that we don't know the state. So I like to go through and get all the components changed. I don't want to power them up and have a cap go out or something like that. So let me switch over here to the game, which should be coming in, and we've got me there on the camera still. So let me go ahead, and I've got a little remote control on the bench here. I can power the board up. You hear the little turkey come in. There's a little relay on the board as well. And I've got a PlayStation controller. I've showed this in some of the other videos. This was a little tricky because these the guns in these games have basically 2 optical encoders, one for, we'll say, up down y-axis, and then one for left and right, which would be your x-axis, and they do that through encoding, optical encoding. And many games we're familiar with, like a binary output or something. This actually uses what's known as gray encoding. So it was a little hard to figure that out. I had some help from a couple people. Fred, who does the FPGA Catbox, helped out figure out what that code was, and we've got it. I got it all decoded, and then I was able to program that in Arduino that then is driving this board to simulate those optical guns. So you can see the game boots right up and goes into a track mode here. Looks pretty good. Hopefully, let me turn up the volume a little bit. I'm not sure if we can hear that. Yeah, there we go. Not sure how horrible that's going to be once we start. So I'll coin it up. It's pretty difficult to play with this controller. It's great for testing it, but it's not really good. It's hard to control because I'm using this little analog joystick. I'll shoot a grenade over there. I didn't get anybody with the grenade. Oh, they got the money. So as you can see, it's playing really, really good. I'm going to drop into diagnostics here. So no ROM errors detected. Here's where it does a RAM test. Again, it's a similar, what we see the rug pattern. It's a similar test. They just write random data to the RAM and then read it back. And so the way these boards, similar to the other earlier ones, whatever's in the RAM gets read out. No RAM errors detected. CMOS is good. We kind of validated that for the most part by seeing that, the game booted right into a track and all the high scores were there. Nothing was corrupted. So this is what we're going to do here. I'm going to switch over to a different cam here. So let's see here. Bench. So you can see I'm going to drop through. That's sound line 1, sound line 2, and it'll just keep looping on these. I'm using the controller to loop through. Sound line 3, 4, 5, 6. And then here's where it gets interesting. So grenade, these are outputs on the board. And, again, most of the Williams games, we're not used to having the board actually outputting something to the real world. But you can see on the bench here, I'm going to point over here, we've got a flashing lamp. And I do have a mode here where I should be able to switch over to where I can flip these around. So here you can see this says grenade lamp. I've labeled this, so I put a little LED and a resistor in series. So I'm driving that. I should still be showing the game in the background. I'm going to toggle now to the next mode, which is the gun lamp. Let's see here. So now the other LED here, the first one is for the gun. And then, again, these are LEDs that flash on the game, telling you the grenade's ready and the gun and that. And then the next mode actually drives an output. So this is for the feather blower. So what I did on the bench here is I've actually got these little mechanical relays. And they have an LED on them. Whoops, I'm not showing it very well. So you can see I wrote feather on this one. So we have a real load on here. The real solenoid draws a little more current, but these are being driven off these transistors with these heat sinks. And so I wanted a real load on there, so simulated an inductive load. And then this one is the gun. This will be the equivalent of the haptic feedback, if you will, the little recoil on the gun when you pull the trigger. So if I switch now over to that other mode, the last test point, gun coil, you can see here this is flashing, and they do a little different frequency on the pulsing on that. So that's the gun board. Again, this board takes in inputs for the left and right and up and down from the optical encoding, the gray encoding, and then this connector over here has all the inputs from the buttons and switches, your grenade and all that. These are your outputs that drive the LEDs and lamps. And over here, this actually takes internal or external power directly from the transformer as the AC input and rectifies it through the bridge to create the power needed to drive the solenoids and stuff. And it also, this is your lamps, your normal coin reject lamps and stuff. So I have a little LED here to verify that circuit. So basically with the setup I have here, I can test all the functionalities on this board. And then all of the gun and all that data is encoded and sent through these two connectors here, these two 12-pin connectors over to the main board. And this is, again, a bi-directional because we can the main CPU board can drive all of these different outputs as well. So let me switch back over to the game. So there we go. And then after this, I can drop into So here's where we go into switch test. So this is where I can test all the inputs coming into the board. So we've got advance. Normally I can't test this on boards because as soon as you hit advance, it takes you to the next screen. But they actually put a time delay in here, which is kind of smart. So you have to hold it for a few seconds before it goes to the next screen. And then we've got auto up. Let's see here. Player 1 start, player 2 start, fire, grenade, gobble. And again, I'm just hitting buttons here that I've kind of mapped on my PlayStation controller. And the fire. The interesting one here, though, is I've got the analog joysticks. You can see where it says horizontal and vertical, and those binary numbers on the bottom represent the gray encoding for the value. So as if I move the joystick left and right, you'll see those go from, up and down, and then the left and right, and their default, ideally, is centered, right? So that's when the gun is kind of pointing at the center of the screen. This would be the feedback from the system, and then as you move left and right and up and down, the cursor on the screen, the dot, would move accordingly. So the next screen we have should be the kind of what they call a calibration. I'm trying to get this to advance over. I might have bypassed it. Yeah, it goes into color bar checking. And then this, you have your normal grid lines for doing convergence, and then you get red, green, blue, color bars, and bookkeeping data, and then back to the game adjustments, and back to a track mode. Let me try dropping in real quick to that calibration mode. It's sometimes tricky to get, if you hold the advance button for too long, it there it is, gun alignment it's called. So as you can see, I've got the cursor here, and I'm just moving the little joystick, the analog joystick down here, back and forth. So this is if you're setting up the game, you can kind of point the gun at the center of the screen, and the adjustments for these on the actual game are mechanical. So there's little slides where you can move the optical switch, the sensors back and forth, and ideally the goal is to get the dot. When you're looking over the sights on the gun, put that white dot right there in the center of the screen. And so this is a helpful screen. I think some of the earlier prototype versions that are the ROMs that are labeled Proto and things like that don't have this gun alignment, but I'm not 100% sure. I haven't tested every version of the code that may be out there. So in any case, that should wrap up this video. I'm going to get this boxed up. This has ran probably 70 hours on the bench. I had a couple things this weekend pop up that I couldn't do the video right away, so I just left the board running. It's been rock solid. And I'm going to get it boxed up and back to the customer, and hopefully they'll get their game up and running shortly. So thanks for watching the video. Much appreciated.